Installing a single multiple pole disconnecting means to simultaneously break both 480 volts AC motor conductors and 120 volts AC control conductors is permissible according to the National Electrical Code, or NEC. NEC section 430.102b states that motor disconnecting means shall simultaneously open all ungrounded conductors to the motor. NEC section 430.103b says that the disconnecting means shall be capable of being locked in the open position. Motor disconnecting means must open all ungrounded conductors supplying the motor, which would include the 480 volts AC motor conductors. Multiple pole disconnecting means are designed to simultaneously open multiple circuits, such as the 480 volts AC motor conductors and the 120 volts AC control conductors. Locking in the open position prevents accidental closure of the disconnecting means, ensuring safety during maintenance or troubleshooting. Therefore, installing a single multiple pole disconnecting means to break both the 480 volts AC motor conductors and the 120 volts AC control conductors meets the requirements of the NEC. Consider the application of NEC Article 430, which covers motors, motor circuits, and controllers. The proper selection and installation of disconnecting means are critical for ensuring the safety of personnel and equipment. When selecting a multiple pole disconnecting means, it's important to verify that it is rated for the voltage and current requirements of both the motor circuit and the control circuit. Ensure the disconnecting means has a sufficient interrupting rating to handle any potential fault currents. This interrupting rating, measured in amps, indicates the maximum fault current the device can safely interrupt without failing. A disconnecting means must be readily accessible, meaning it should be located where it can be easily reached without having to climb over obstacles or move equipment. This accessibility is crucial for quick response in emergency situations. The disconnecting means must be clearly labeled to identify the equipment it controls. This labeling helps prevent confusion and ensures that the correct circuit is energized during maintenance or repairs. The NEC requires that the disconnecting means be capable of being locked in the open position. This lockout/tagout capability is essential for preventing accidental re-energization of the circuit while work is being performed. Use a padlock or other locking device to secure the disconnecting means in the open position, and attach a tag indicating that the circuit is being worked on. The multiple pole disconnecting means should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. Proper installation ensures that the device functions correctly and provides reliable protection. Regular inspections and maintenance of the disconnecting means are important for identifying and addressing any potential problems such as loose connections, damaged components, or corrosion. Address any issues promptly to ensure the continued safe and reliable operation of the equipment. Remember that the control circuit conductors must also be properly sized and protected. Overcurrent protection, such as fuses or circuit breakers, must be provided to protect the control circuit conductors from overload and short circuit conditions. The size of the overcurrent protection device should be based on the ampacity of the control circuit conductors. Also, consider voltage drop in the control circuit. Excessive voltage drop can cause the control circuit to malfunction, leading to unreliable operation or even equipment damage. To minimize voltage drop, use appropriately sized conductors and keep the length of the control circuit wiring as short as possible. When working with electrical equipment, always follow safe work practices and wear appropriate personal protective equipment or PPE, such as safety glasses, gloves, and insulated tools. Ensure that you are properly trained and qualified to perform the work. If you are not comfortable working with electrical equipment, seek the assistance of a qualified electrician. Understanding the NEC requirements for motor disconnecting means and following safe work practices are essential for ensuring the safety of personnel and equipment. By carefully selecting, installing, and maintaining multiple pole disconnecting means, you can help prevent electrical accidents and ensure the reliable operation of your facility. The proper coordination of overcurrent protection devices is crucial for electrical system safety and reliability. When multiple overcurrent protection devices are installed in series, such as a main breaker and branch circuit breakers, they must be coordinated to ensure that the device closest to the fault opens first, minimizing the impact on the rest of the system. This coordination is typically achieved by selecting overcurrent protection devices with different time current characteristics. Devices closer to the load should have faster tripping times than devices further upstream. A selective coordination study can help determine the appropriate time current characteristics for each overcurrent protection device in the system. This study involves analyzing the potential fault currents at various points in the system and selecting devices that will coordinate properly under all fault conditions. The NEC provides guidelines for selective coordination in Article 240. It's important to consult the NEC and other applicable standards when designing and installing electrical systems to ensure that overcurrent protection devices are properly coordinated. Regular testing and maintenance of overcurrent protection devices are essential for ensuring their continued reliable operation. Circuit breakers should be periodically tested to verify their tripping characteristics, and fuses should be inspected for signs of damage or deterioration. Any devices that fail to meet the manufacturer's specifications should be replaced immediately. Another aspect to consider is grounding and bonding. Proper grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip overcurrent protection devices quickly and safely. Bonding ensures that all metal parts of the electrical system are at the same potential, which reduces the risk of electric shock. The NEC provides detailed requirements for grounding and bonding in Article 250. It's important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. Ground fault protection is another important safety feature that can help to prevent electrical shock and equipment damage. Ground fault protection devices, such as ground fault circuit interrupters, or GFCIs, and ground fault equipment protection, or GFEP, are designed to detect ground faults and trip the circuit before a dangerous amount of current can flow through a person or equipment. GFCIs are typically used in residential and commercial applications to protect people from electric shock, while GFEP is typically used in industrial applications to protect equipment from damage. The NEC requires ground fault protection in certain applications, such as bathrooms, kitchens, and outdoor locations. Surge protection is another important consideration for electrical system protection. Surges, or transient overvoltages, can damage sensitive electronic equipment and even cause fires. Surge protection devices, or SPDs, are designed to protect electrical equipment from surges by diverting the surge current to ground. SPD should be installed at the service entrance and at any other locations where sensitive electronic equipment is located. The NEC provides requirements for surge protection in Article 280. Harmonic distortion can also cause problems in electrical systems. Harmonics are sinusoidal currents or voltages with frequencies that are integer multiples of the fundamental frequency. Harmonics can be generated by nonlinear loads such as electronic ballasts, variable frequency drives, and computers. Harmonic currents can cause overheating of transformers and conductors, as well as misoperation of sensitive electronic equipment. Harmonic filters can be used to reduce harmonic distortion in electrical systems. Power quality monitoring is another important aspect of electrical system maintenance. Power quality monitoring involves measuring various electrical parameters such as voltage, current, frequency, and harmonic distortion to identify and diagnose power quality problems. Power quality monitoring can help to prevent equipment damage, reduce downtime, and improve energy efficiency. Regular maintenance of electrical equipment is essential for ensuring its continued reliable operation. Electrical equipment should be inspected regularly for signs of damage or deterioration. Connections should be checked for tightness, and insulation should be inspected for cracks or breaks. Any damaged or deteriorated equipment should be repaired or replaced immediately. Thermographic surveys can be used to identify hotspots in electrical equipment, which can indicate loose connections, overloaded circuits, or other problems. Infrared cameras are used to scan electrical equipment and identify areas of elevated temperature. Addressing hotspots promptly can help to prevent equipment failures and fires. Furthermore, be sure to use proper wiring methods. The NEC specifies the types of wiring methods that are permitted for different applications. It's important to use the correct wiring method for the specific application to ensure that the wiring is properly protected from physical damage, moisture, and other environmental factors. Conductors must be sized correctly for the load they will be carrying. The NEC provides tables that specify the ampacity of different sizes of conductors. It's important to select conductors with sufficient ampacity to carry the load without overheating. Overloaded conductors can cause fires. Also, ensure proper conduit fill. The NEC specifies the maximum number of conductors that can be installed in a conduit of a given size. Exceeding the conduit fill limits can cause overheating of the conductors and make it difficult to pull the conductors through the conduit. Always use approved electrical equipment. The NEC requires that all electrical equipment be listed or labeled by a recognized testing laboratory such as Underwriters Laboratories or all. This listing or labeling indicates that the equipment has been tested and meets applicable safety standards. Do not use unapproved electrical equipment as it may be unsafe. Moreover, be sure to follow arc flash safety procedures. Arc flash is a dangerous electrical hazard that can cause serious burns, injuries, and even death. Arc flash can occur when there is a short circuit in electrical equipment. Follow arc flash safety procedures, such as wearing appropriate personal protective equipment, or PPE, and energizing equipment before working on it to minimize the risk of arc flash injuries. Regarding emergency procedures, it is important to have documented emergency procedures in place for dealing with electrical accidents. These procedures should include instructions for shutting off power, providing first aid, and contacting emergency services. All employees who work with electrical equipment should be trained in these emergency procedures. Another important aspect is electrical safety training. All employees who work with electrical equipment should receive regular electrical safety training. This training should cover topics such as electrical hazards, safe work practices, and emergency procedures. Employees should be trained to recognize electrical hazards and to take appropriate precautions to avoid them.